Okay, so welcome back to lecture 12 of MA 221. So today we'll be mainly discussing about centroids. So say I have a plain sheet like this of a certain mass. The question is, what is the point where the mass is kind of acting? So in other words, what's the balancing point for the plane for the plate rather? So we call that point, say x bar y bar, to be the center of mass. If we put, say, one pin at that point, then the plane should balance on that single pin. Okay, so that means through that point the mass is kind of acting. Okay, I guess this does make sense. Okay, so there are several cases. The very simple one would be one-dimensional case, where you have like a string like this, and say these points are like x1, x2, xd plus 1, and so on till xk. And at these points, so say this is like x-axis, and this are the k points. And on this point, I have different mass, say m1 at x1, m2 at x2, md at xd, md plus 1 at xd plus 1, and so on till mk at xk. Then the question is, for this you know system of masses, what will be the point of center of mass? Say x bar is the center of mass, and there are like d points before that, namely x1, x2, xd, and the rest of the points are right of that center of mass. Then what happens is, this up. Okay, so let me do some calculation. So when this string of points will be in balance, if I have m1 d1 plus m2 d2 plus so on, say m d dd is same as md plus 1 d plus 1 plus so on mk minus 1 dk plus mk. Okay, cool. There's a mistake. It should be. So this m1, m2 are mass, and d1, d2 are like distance from each of these points to the center of mass. So d1 will be this distance, d2 will be this distance, and so on. Similarly, for this point, d plus 1, this distance will be like dd plus 1. What is dk? dk is distance from this point, kth point, to the center of mass. Okay, like that. Okay, so therefore m1, what is d1? d1 is basically x bar minus x1, right? m2 x bar minus x2, plus so on. On the right, I have md plus 1 x bar minus, okay, there I'll have x d plus 1 minus x bar, because now d plus 1 is on the right, so d plus 1 minus x bar will be positive quantity. So on till mk xk minus x bar. Okay. And this is nothing but m1 x bar plus m2 x bar plus so on, mk x bar. I'm just collecting all the terms where I have x bar and writing that on the left hand side. And the right hand side, I will have m1 x1 plus m2 x2 plus so on, mk xk. Okay. Cool. If I take x bar factored out, then I'd have m1 plus m2 plus so on plus mk to be m1 x1 plus so on mk xk. And this implies x bar is m1 x1 plus so on mk xk over m1 plus m2 plus so on mk. Okay, so this is the formula that we need basically to solve problems. Okay, cool. Okay, let's see one problem now. So example, find the center of mass for the point mass is located on the x-axis as shown. To say I have 0, 2, 3, and say 6. These are my points. And at 2, I have a mass m1 to be say 10, m2 to be say at 3, 5. At 6, I have m3, which is 15 unit. Okay. So what is the total mass? Total mass will be just sum of all this 10 plus 5 plus 15, which is 30. And if I consider moments, okay, so this quantity is called moments. M1 x1 plus M2 x2 plus so on. Mk xk is called moments. Okay, so the moments will be M1 x1 plus M2 x2 plus M3 x3, which is 10 times 2 plus 5 times 3 plus 15 times 6. Okay, which is just 20 plus 15 plus 90. In total, it will be like 205, I guess. No, no. Okay, no. It would be 1, 1. Right? So therefore, my center of mass x bar will be just 125 over 30, which is approximately 4.166. That's my answer. Okay, cool. Now, the case 2 will be when you have a rod of variable density. Then for that rod, what will be your center of mass? Say Ex is the density of density at, sorry, X, which is in kg per meter. So say I have a rod which is like of length b minus a, so therefore they are like this. So this is my rod, and if I consider a small section of it at say x, and that small section has length dx, Then dm, which is also known as mass of slice of thickness, say dx, will be ex dx kg, right? Because ex was the density of the rod at x, and the length of the rod is dx. So therefore, if I multiply with the length, then I'll have the mass, right, of that small piece. Now, what is total mass? For total mass, I have to integrate, right? Total mass m is just a to b ex dx. Okay. And what is total moments? Total moments, say m1 will be a to b, then x ex dx, right? Because remember, moments were what? Mass, each of the small masses, point masses, times times where they are at, and you take all of those sums, right? Right there. So for this case, I'm just doing the same thing. Uh, this is the density at x. I'm multiplying with the point, which is x, and then I'm integrating to have the total mass. So things are like in sync. So center of mass will be x bar, which is m over m1, or I'm wrong, m1 over m, which is just, I mean, you can just write that down, a b x ex dx over a to b ex dx. That's it. Okay, one example. Let's see. So you have a rod of length 2 meters, having density rho x to be 1 plus x kg per meter. Say x measured from left end, and then you have to find x bar, the center of mass. So let's draw a picture. So this is 0, this is 2, and so the rod is like this. Okay. So at 2, at this, sorry, at 0, at the point 0, my rho 0 will be 1 kg per meter, right? That's the density there. At 3, the density will be 3 kg per meter using this function. Okay, cool. So now my total mass by the formula, say m will be 0 to 2, 1 plus x dx. This is easy to calculate. You will get the answer as 4 kg. And moments m1 will be 0 to 2 x 1 plus x dx. This is also easy to calculate. The answer will be, I guess, 14. It will be x squared 2 plus x to the 3 over 3, 0 to 2, right? Which is like 2 plus 8 over 3, 3, 14 over 3, and then your x bar is just 14 over 3 over 4, right? Which is m1 over m. And then this is just 14 over 3 times 4, which is 7 over 6 meter. So therefore, the center of mass will be, say, So this is 1, so this is like 7 or 6. Right there. This is the center of mass. Okay. So far, so good. Okay, the other case might be like this. When you have two-dimensional system of points, rather point mass. Okay. What is that? Say we have, instead of a line, now we have a plane, and you have, say, different points. You have different point masses at different points. Say at x4, y4, you have m4. Say at x1, y1, you have a point mass m1. There is m2 at x2, y2, and say x3 at x3, y3, I have point mass m3, like that. So this forms kind of a system. Then my question is, what will be the point of center of mass, x bar, y bar? So the same idea kind of goes, and the formula is kind of same. Say total mass is m1 plus m2, say mk, when you have like k different points, k different point masses at different points. And then say mx is moments about x-axis. That means what? That means you will multiply each of the mass with the abscissas. Say at m, so m1 is at x1, y1. So I'll just take m1 times y1 plus m2 times y2 plus so on. Mk times yk. And for my, I'll do this same thing, but just now considering the first coordinates of the point. So moment about y-axis, which is m1 x1 plus m2 x2 plus so on, mk xk. Right. And then the center of mass will be x bar y bar, which is just so for x bar, what is x bar? X bar is my over m, and y bar is mx over m. Okay. Cool. Let's see one example. So say my example is like this. Find the center of mass x bar y bar for the point masses shown. Say I have the points as 1, 3, and at that point my mass is 5. I have the point like 6, 2, and that point I have the mass 10, and I have 2, -3. At that point I have mass say 8. Then what is x bar? So remember, x bar is my over m. M is fine, just sum of all the masses, 5 plus 10 plus 8. What is my? My is m1 times the first coordinate plus m2 times the first coordinate and the second coordinate of the sorry. My is m1 times the first coordinate of the first point plus this second mass times first coordinate of the second point, and so on. So this will be 5 times 1 plus 10 times 6 plus 8 times 2, which is just 65 plus 16, 81 or 23. Similarly, y bar will be m1 y1 plus m2 y2 plus m3 y3 over the sum, which is 5 plus 10 plus 8. What is m1 y1? m1 is 5, y1 is 3, m2 is 10, y2 is 2 plus m3 is 8 and y3 is -3, and there is 23 in the denominator. If you calculate this, you'll get 11/23 as the answer. Okay, so not too difficult, I'd say. Okay, now the last case is when you have something like this. Find the center of mass for a two-dimensional region of uniform density E. Okay, what's the picture looks like? So say I have, say, a region like this in two dimension, which goes from A to B, and say E is the uniform density. What's that mean? That basically means that so over the region, the density is kind of constant. Okay, so again, I'll consider a small sheet of length dx at say x. Then the mass of the sheet, or rather, I'd say slice, is dm notation, which is e times fx minus gx, right? Easy to see. Right, because E is the constant density, and then um, what is the area of this small slice? There should be dx. Okay, maybe just write it down. Okay, this is basically the area, and this is the uniform density. Okay, area of the small slice. Okay, how do I get that? Maybe the picture will be helpful. What is this distance? This is f minus g, right? This distance, this length, and this is dx. So therefore, the area will be this length times this width. So therefore, that is here, right? So here. And now for the mass, I need to multiply that with density. So it kind of makes sense. What is the moment of slice uh, about x-axis? Here I had two dimension, right? So I need to consider moments about x-axis, also moments about y-axis. This is dmx notation, which is basically dm times half fx plus gx. Okay, this is basically coming out of from a formula, just like the previous ones. Okay, just multiply uh, the masses, and then you just take the average of the length of this small slice. And if you put the expression for dm right there, then it will be half e times fx square minus gx square dx. Okay, cool. So far, so good. Okay, what about moments of slice about y-axis? is dmy, again notation, which is dm times x, right? It's about y-axis, that should be x, right? Because when you consider about x-axis, this direction, then remember the formulas are kind of like odd. So you need to consider y just for consistency. When you consider moments about x-axis in the previous type of problem, you consider m1 times y1. So see, there is x, there is y1. So there is a opposite kind of relation between them. So here also, when you consider the moment about x-axis, you consider about the distance, these distances, like this, about like different slices. Okay, this is a little bit hard to visualize, but I hope you understand. Okay, and when you consider y about y-axis, then you should go like through x, but x is sort of like there is no kind of change in x, so therefore I have just dm times x there, right? Okay, and now if I put the value of dm again, I'll get this expression e times x fx minus gx dx. So therefore, for the whole, like for the whole region, this is for the slices, right? For the whole region, basically I have to integrate. M would be a to b dm, which is e times a to b fx minus gx dx, right? Because dm was this. When you integrate, you'll get this. Mx is integration dmx, right? Dmx was this. So it will be half times e a to b fx square minus gx square dx. And my would be integration dmy, which is e times a to b x fx minus gx dx. The same thing, we just integrate this quantity. Okay, cool. So the center of mass or centroid for this region, x bar y bar, where x bar is just my over m. In other word, a to b x fx minus gx dx over a to b fx minus gx dx, and y bar is mx over m, which is a to b half times fx square minus gx square dx over a to b fx minus gx dx. Remember, all the e that are like in front will be cancelling out with the numerator and denominator, like that. Okay. There are two remarks. Number one is for computing centroids, we can assume the density is 1. Because see, in the calculation of centroid, there is no E, right? There is no involvement of E. So therefore, for simplicity, we can just ignore that in this way. And the other thing is, remember, fx minus gx dx is the area of the region, right? So sometimes if you know something very similar, uh, region of your knowledge, for example, say circle, you do not have to like calculate it. You basically can use pi r square or something. Yeah. Anyway, let us see one example for this type. So the question is, you have to find the centroid of the region bounded by, say, y to be 4 minus x squared, and then y equal to 0, x equal to 1. So if you draw this, you'll get the picture like this: -2, this is 1, this is 2. So this will be like this. So this thing will be this, but then I have to consider only the region bounded by x equal to 1. So this is x equal to 1. So my concerned area is this. Okay, cool. Now, if I calculate the total mass, it will be -2 q1 4 minus x squared dx, right? Because this is the like the upper function between fx and gx. So I have say this is fx, this is gx, right? So for mass m, remember I have to integrate a to b fx minus gx dx. So here this is my fx and this is my gx. So therefore 4 minus x squared, which is this 4 minus x squared, and this is 0, right? Y is 0. So therefore minus 0 doesn't come there. So I have to just calculate that. If you do the standard calculation, you'll get the answer as 9. So that's the mass. And for my, remember I'm just supposing I'm just supposing this E to be 1. Because at the end, it doesn't matter. So you can just assume E to be 1 to make things simpler. Uh, okay, so this is x times fx minus gx dx. Okay, so again, it should be from -2 to 1, x times fx is this, gx is 0, so it doesn't appear there. So this is that, and then if you again calculate this, you'll get -9/4. And if you calculate mx, the same kind of calculation from -2 to 1, and then half times 4 minus x squared whole square. That's not the extra dx. And then this is also not difficult. You have to like use the a minus b squared, that formula, but maybe I just write one more line in there. It will be -2 to 1 half times 16 minus 8x squared plus x to the 4 dx. And then if you calculate this, it will be 15.3, I guess. Yeah. So my y bar will be mx over m. So 15.3 over 9, so which is 1.7. And my x bar will be my over m. What was my? My was 9. So 9 over 9 is just 1. What was my? Oh, okay. Sorry. My bad. It's not 9. It is -9/4. So -9/4 over 9, which is -1/4. Right. So my center of mass is x bar y bar, which is -1/4 and 1.7. That's my answer, basically. Okay, so this is basically it about centroids. I hope you'll be able to solve the homework, the problems in homework 3. And if you have any doubts, questions, you can meet me in the office. Thank you.